Derivatives of implicit functions. Until now, we have been differentiating various functions given in the form y is equal to f of x. But it is not necessary that functions are always expressed in this form. For example, consider one of the following relationships between x and y. X minus y minus pi is equal to 0 and x plus sine of xy minus y equals 0. In the first case, we can solve for y and rewrite the relationship as y is equal to x minus pi. Whereas in the second case, it does not seem that there is an easy way to solve for y. Nevertheless, there is no doubt about the dependence of y on x in either of the cases. When a relationship between x and y is expressed in a way that it is easy to solve for y and write y is equal to f of x, we say that y is given as an explicit function of x. In the latter case, it is implicit that y is a function of x, and we say that the relationship of the second type above gives function implicitly. In this subsection, we learn to differentiate implicit functions. It is given that 2x plus 3y is equal to 7y. Differentiating with respect to x, we get 2 plus 3 into dy by dx is equal to cos y dy by dx. Now collecting all the dy by dx together, we get dy by dx cos of y minus 3 is equal to 2, or therefore dy by dx is equal to 2y cos y minus 3. The second one is sin squared y plus cos xy is equal to pi. Differentiating with respect to x, we get 2 sin y cos y into dy by dx plus cos of sine of, this is now going to be, when you differentiate cos, it will now become minus sine of within brackets you have the angle to be xy, so it has to be differentiated using the product rule. So that would give you sine of xy into u is x, dv is y, v is y. So when I differentiate y, I'll get it as dy by dx plus v is y. When I differentiate x, I'll get as u dash is 1, which is equal to 0, because constant, when you differentiate a constant term, it is now going to be 0. Now this becomes 2 sin y cos y into dy by dx minus sine of xy into x dy by dx plus y is equal to 0. Or collecting all the dy by dx together, we get, now 2 sin y cos y is nothing but sine of 2y into dy by dx minus sine of xy into x dy by dx minus y sine of xy is equal to 0, or collecting all the dy by dx together, we get dy by dx as into sine of 2y minus x sine of xy is equal to y into sine of xy. Or we want only dy by dx, so therefore dy by dx is equal to y sine xy divided by sine of 2y minus x sine xy.